they are mostly site to site. Of course, we can configure them with point to multi-point as well, mostly point to point. We can still configure point to multi-point options, but again, this is like limited. The more number of multi-point sites you connect, the configuration goes very, very high. The amount of configuration you end up doing on one single router is going to be a lot. It's not like a normal options. Okay, so basically that is one limitation we can say. And the other thing is the same interface is used for both internet as well as your normal LAN traffic. Now how this works is we are going to configure an ACL, if you remember, with an interesting traffic, and saying that if the traffic is going from 1 dot network to 2 dot network, that is going to be secure, where the IPSec traffic is IPSec to be applied, and it lives on the same interface, because on this interface we are applying the crypto map. So whenever a traffic hits this interface, it's going to check if the source and destination matches, then basically it's going to apply the IPSec and send it to this peer, and if not matches, then it's going to send out to the internet without applying the IPSec. So in order to differentiate the traffic, your LAN to LAN traffic and the LAN to internet traffic, we need to write an ACL. And again, if you have hundreds of sites, that's really not an easy job. So you cannot go and write an ACL for each and every site. Again, that is not a scalable option, because the same interface is used. So basically you have to differentiate the traffic which is going to the internet as well as the traffic which is going to the remote LAN. So we always need to define the ACL, as I said, to define the interesting traffic to be sent over the VPN. And again, the issue comes with a NAT, because when you are implementing NAT, the issue is like when you're trying to send a traffic from source to destination, when it hits this when it is leaving the interface, if you have NAT enabled, it will change the source address. So the source address will change to some public IP. Again, that can create a problem for your VPN, because the same interface is used for internet traffic as well as your LAN traffic. We also need to write a deny statement in the interesting traffic in the NAT, ensure that if the traffic is going from 1 dot network to 2 dot network, should not get translated. So again, you have to write another statement saying that don't translate if the traffic is going from 1 to 2, do no NAT. And if the traffic is going from 1 dot network to any other destination, do the NAT, translate them the public IP, but not with this one. So again, you can see the complexity will increase when you are combining the IPSec VPN with NAT. Again, we must configure NAT exemption. That's what no NAT for the interesting traffic. The IPSec traffic should not to translate again. One more limitation is if you are setting up a VPN, we cannot run OSPF or EHRP protocols on this, because in native IPSec VPNs, routing protocol traffic is not allowed, as well as your multicast traffic is not allowed. So basically, you can still communicate, of course, with the help of ACL, interesting traffic. But again, if you have multiple sites, then that is going to be a limitation. So unlike if you see the GRE and the DM VPN options, they do support these two things. They allow the routing protocols to be configured, and dynamic routing is allowed, and you can still send the multicast traffic over the VPNs with GRE or DM VPN, but not with IPSec VPN. So if you have any multicast traffic running between these two LANs, basically that is not supported. So these are some of the limitations which makes IPSec native IPSec. Again, I'm saying native means a normal site-to-site IPSec VPNs we don't use in most cases, especially in the VPN connections. We always prefer to use the DM VPN or the GRE VPNs to support these features with IPSec. So which means we'll be implementing mostly IPSec over these networks instead of running natively as we did in our previous sessions.